Okay, so I belong to INESCTEC, is a research institute in the north of Portugal. I will do a brief introduction of the institute and what kind of things we do. And after that, I will briefly show some of the technologies we use in underwater robotics. And after that, I will show you the world record we won in August this year in the deepest cave on Earth, the natural cave, and it was done with a robot, of course. Okay, so underwater technologies. INESCTEC is a big institute in the north of Portugal, with all the universities are associated to this research institute, and it is divided in 13 centers. So the center I belong is CRAS, so Robotics and Autonomous Systems, and there are plenty of other kind of research inside the institute. Okay, so autonomous robots. For you to have an idea, I started working with robots with a soccer team. So we used to play football with robots. We have been around the world in many different competitions. And then we started to grow quite a lot. The group grew a lot. And in nowadays, we have from underwater to aerial vehicles, from different types of vehicles, from torpedo shapes to landers, to AUVs, hybrid ROVs, drones, many different kinds of robots. We have a swimming, not a swimming tank, but a test tank in the lab where we can validate all these underwater technologies. And also we have okay, this is just some facts and figures about the lab. Okay, this is the lab. So we have the tank where we test all the equipment with 5 meters depth. We also have 2 hyperbaric pressure chambers to validate the equipments in depth. So we have the 750 bar pressure chamber with 1.5 meters long, where we can test all the systems before go to water. And of course, we have CNC, 3D printing, and all we need to build our robots. So these are the pressure chambers. We have 2. The orange one is to 750 bar, and the green one to 400 bar pressure tests. This is our recent research vessel that we have in the institute, that we use to deploy robots in open water, in the sea, mainly in the sea, of course. And it has a capacity to have 9 researchers. It has an A-frame for 1.5 tons. It's a catamaran with 19 meters, and is a very useful tool that we have in the lab. Okay, apart from that, the goal for robotics in this area is to go deep. We want to go deep, and because we want to extend our continental shelf or zone in Portugal, because Portugal is sea, as you know. So we are mainly focused on robotics applications for underwater and underwater exploration, not only in the ocean, but also inland. So for that, I would like to show you a very good project that we had. It's called VAMOS, the Viable Alternative Operating System. That the idea is to develop technologies to extract minerals of open pit mines that are flooded. So we developed some a robot for this scenario to map the mine, and then we put a lot of instruments in a machine that was digging and cutting rock underwater without anyone inside. So this is a completely robotic solution to extract minerals without risk for humans. Okay, so this is the idea, to have a barge on the surface, to have a machine, a mining vehicle underwater, and to have a satellite that we call it a hybrid ROV, because it can work as a ROV or a AUV. And the AUV will be supporting all the operations. Okay, so this is just a video that will show you very, very well and briefly what kind of things we have done in this project. This was an European project, 3 years project. So this is the mining vehicle, and those are the sensors we installed on it. So this is a big machine with 25 tons machine. And no one is inside. This is a semi-autonomous machine. So there is a control room where an operator will control the machine. And all the data that is fed to the control system was done by us. So we put a lot of instruments on the machine and on the vehicle, the hybrid ROV. It's called EVA. I will show you more in detail. So this is the reconstruction with Multibeam that we used to do. This is real image from the machine. You can see that all the water is muddy and with low visibility. Okay, and this robot is EVA, the one that we built for this project to build the map of the mine, as you can see here. So this is what kind of things that we do. That is a 3D reconstruction. This was done on surface in a completely autonomous mission. So we just put a mission on the vehicle, and the vehicle will do the survey by itself. Okay, I will skip this. Okay, so I would like to show you this, because in the morning talks you probably saw Marco Pires' presentation, and in collaboration with the Portuguese Navy, after the trial we have done in Limur for the Vamos project, just after we arrived, we received a call from the Portuguese Navy to try to help to find the cars that were in the quarry disaster. The problem here, like Marco said, the visibility was completely zero visibility. The communications down there are zero, no GPS. So since this robot was not built for open waters and to have localization through only by GPS, but also with acoustic sonars underwater, we managed to build a map of the bottom with an acoustic sensor. It's called an Echoscope 3D imaging sonar. And you probably cannot see very well here, but later I can show you. These are the two cars that we mapped with the robot. So we tell the divers, okay, one car is here and another car is here. And they went there, the divers went there and grabbed the two cars. It's not very good, the image here. I will show you in my computer if you would like to. But we can see very well that one of the cars is upside down and one of the wheels is off. Okay, we also have another collaboration with the Portuguese Navy. I've been in this ship traveling 32 days across the Atlantic in a world trip. The idea was to build the electric field of the Earth with this boat that was supposed to do the circumnavigation around the world. But then the trip was canceled because of the pandemic COVID situation. Another project, very interesting, it was this one, the IPERC, where this was this year also, we were able to capture a live species at 900 meters depth. So we developed this kind of robotic solution that we deployed at 900 meter depth. And we kept the species that get in the capsule alive in pressure and bring them to surface in pressure. And then we managed to transfer the species to another pressure chamber, and it has been later on evaluated, the species and their behavior and so on, by the Portuguese Association for Ocean and Atmosphere, another partner. Okay. My presentation now will focus on a very particular problem that we are facing in minerals and mineral deposits in Europe. As you know, we have a lack of minerals in the whole Europe, and we are buying a lot of minerals around the world. And we decided to apply for a funding for the Horizon 2020 because there are more than 30,000 mine sites closed in Europe. And there are a huge impact in this, in cultural heritage, historic, and also the viability of reopen, and also to study the terrain stability of these kind of gallery mines. Most of these mines are flooded. So since they are not profitable, they switch it off the pumps and they are completely flooded. So there is an unknown map and state of these mines. Most of them have more than 150 years and probably more, some others. And with this, exploration is very difficult and expensive, and we can help this with robots. So with this idea, we started a project called Unexmin in 2016 with 13 partners, 4.8 million. And after Unexmin, we were founded to create a company. It's called Unexmin Robotics. And we started the project UX1 that's still ongoing, and I will show you in a few minutes. So we have been testing these robots in Katiala in Finland, in Idria, Slovenia, in Urgerice in Portugal, Acton in South Crofty, UK, in Ukraine, in Hungary, in Xor, Molnarianos, and Kobania. So we have done hundreds of dives with these robots. So this is again Unexmin, and I will try to be fast because I still have a lot of slides. Okay, so as you know, diving in unknown environment is very, very challenging because there are narrow galleries, a lot of obstacles, a lot of unknown things that before we dive, we don't know what the kind of things we can find there. Most of the mines have vertical shafts, horizontal shafts, but some of them also have inclined shafts, and what makes the things difficult. Okay, so before we start, we looked into this science fiction. So this is from Prometheus. You probably have saw this before. And our idea was to build something like this. So this is what we want. We want robots that we deploy and they will build a map. Okay, but this was not underwater, because underwater it's much difficult. In underwater, as you know, we don't have localization. There is no satellite communication. There is no bandwidth communication, only acoustic at low bandwidth. So it's very difficult to localize robots. Anyhow, we developed a kind of spherical robot in Unexmin could be similar to the one that we saw in fiction. Okay, so this robot is called UX1. For this family of robots, we have UX1 A, B, and C. So we have 3 robots. It's a spherical shape, 0.6 meters in diameter. The maximum depth is 500 meters, maximum speed 0.5 meters per second, and it can last 5 hours diving. Okay. Okay, so it has a aluminum hull, scanning sonar, multibeam in the front to reconstruct, to do the 3D map. It has a SLS, is a structured light system that we developed our own, that combines lights and laser to also create 3D map at high resolution. And it has 8 thrusters, and inside there is a pendulum system that that makes possible the robots to rotate without losing energy or not using the motors. Okay, so the sonar we are using is a multibeam from Kongsberg. It has 256 beams, 3 degrees beam width, and 120 field of view. So this let us create a very, very precise 3D map for navigation and perception, even when we don't have any visibility, because with the sonar we don't need to have visibility to create the environment. It is also possible to use the M3, the multibeam, as imaging, not in profiling but in imaging mode. So you can see there a stair. So this is like having an image in that ray. Okay, the structured light system is a light projector system that we developed with a laser line and white LEDs, and we combine both light sources to get a 3D reconstruction. So for better understanding, I try not to go too very in detail in the technology, but as you can see here, this is underwater in our test tank, and there is the camera and the laser, and this is the result. So you can see on the left bottom the color image, so LED image, and on the top left you can see the laser. So the combination of two with a lot of software on top of it and processing, we can build a 3D model of what we are seeing with color. So we get all the points and distance, and then we put the color of the corresponding pixel in the camera. So you can see here, this is a grid of 20 by 20. So we have a sub-millimeter resolution with this laser system. The big question is, how far can we see with this? Okay, it depends on the water quality or visibility, but usually and typically to have very good results, it's between 2 and 3 meters, not more than that. Okay. Okay, so this is a very good movie that I would like to show you.
Traditional geological methods are extremely expensive and dangerous when it comes to evaluating flooded mines. The Unexmin team has been set up to develop an autonomous robot solution called UX1, which will autonomously map the abandoned flooded mines and gather valuable geological and mineralogical information. The engineers and scientists are representing 7 countries. The most challenging task is the miniaturization. All the gadgets have to fit in a spherical robot only 60 centimeters in diameter. The UX1 builds up a real-time 3D model of its environment by analyzing and combining flow meter, sonar, laser beam, and accelerometer information. Using the sensors, the robot can identify all the potentially interesting minerals under the harshest conditions.
Okay, so this explains a bit the project. There is another movie. I don't know if I have time. Do I have time, Arlindo? Yeah.
Welcome to the Acton Mines.
Okay.
There are thousands of abandoned mines in Europe. Acton,
okay,
England,
so let's pass to other one. This was another movie explaining one of the trials. Okay, so some of the results. So we mapped these mines. We can see here some of the results. We have done with more than 50 dives with this robot, 98 mission hours and 5 kilometers traveled. And these are also some of the results of the real-time navigation and map building that I would like to show you. And now I will pass to the second generation of these robots. It's called the UX1-Neo. It's a new solution with an open frame solution, not a closed frame hull, with many different sensors and more. We can stay more hours in the water. This robot can last 8 hours in the water. It also has a spherical shape. The maximum depth still in 500 meters because of some sensors that we are trying to replace. And this is a European project funded by EIT Raw Materials, the European Institute of Technology. And we are diving with this robot almost every month. So the robot has almost the same sensors, but more in total in number of sensors. So in this one, we have synthetic foam to keep the buoyancy. We also have internally a system like Avelo, the variable buoyancy system that will let us calibrate the buoyancy of the robot depending on the water density. It has cameras in all the sides of the robot, acoustic sonar for collision avoidance, and multibeam on the front. And there is a small video also of this robot. So this is in a mine that you divers probably know, in Molnár János in Hungary. This mine is a mine where divers go to train cave diving. And there are guiding lines that we could follow with the robots, and also program missions to do the survey automatically. Okay, so some of the results that we could see here with the laser, the SLS. So that this is a reconstruction of the bottom. There is a diver that we scanned with the robot, just as an example. This is some tests that we have done with fully autonomy. So the robots have done this mission following that corridor with stairs, completely autonomous, without any cable. Just we programmed the mission and said, follow these walls. When you don't see a wall in front of you or in the laterals, just turn around and come back. And this was a very good test that we have done recently also. Okay, about the deepest dive in the freshwater cave. It was in August this year in Hranice Abyss in Czech Republic. So the abyss have been mapped for 50 years or so by divers, but they don't know exactly what is the maximum depth of this cave. This natural cave maximum depth we cannot see here, but it was reached 232 meters, if I'm not mistaken, by a diver in 2015. And in 2016, there was a robot from Graal Marine in an expedition of National Geographic that reached 404 meters. So this year we were invited to go there and try to beat the record and try to map the cave. And we end up on the 450 meters with the robots, because we didn't want to push to the limit of the robot, that is the 500 meters. So we decided to come back after 2.5 hours diving. But we didn't reach the bottom, so no one knows what is the maximum depth of this cave. So these are some of the results. So we mapped very well the the cave. The shape is it's very interesting. For me, that picture, the left picture, is a result because we recovered the vehicle, so it came back. It's a result. And yeah, so just to finish, I would like to show you this video to have a better understanding. And that's all. Hello. Ah.